Now we're going to talk about a numerical analysis of limits. So when you see numerical, that means a table of values. And so we're going to look at this function, 2x squared plus 5x minus 3 over x squared minus 9, and use it to try to find these limits. So the limit as x approaches negative infinity, and the limit as x approaches positive infinity. Now you see that there are already x values filled in this table, but sometimes you're going to have to fill those in on your own. So let's think about why you would use these. So we're thinking about x approaches negative infinity. Those are large numbers but negative. So we would go negative 50, negative 100, negative 500, negative 1,000. And then the same thing for positive infinity. Now these are not numbers that you want to plug in and try to calculate by hand. So we're going to use our calculator, our handy Desmos. I've already typed this in here, so type in that function, and then remember you can click the gear and then make a table of values. And then we're going to type in those numbers. Negative 1,000, negative 500, negative 100, negative 50, positive 50, 100, 500, 1,000. And then let's go ahead and fill those values in on our table. All right, so this was 1.995, 1.990, 1.951, 1.906, and then for the positive side, 2.106, 2.052, 2.010, and 2.005. So we have those values in our table now, but let's think about what they actually mean. So this says limit as x approaches negative infinity. So I'm looking for my x values to be getting larger, but in the negative direction. That's this way, negative infinity. So I'm trying to look at my y values, seeing if they're approaching anything. I would say it seems like they're approaching positive 2. And so this limit is 2. On the other side, I'm looking for x approaches positive infinity. These numbers are getting larger in the positive direction. So I'm going to check out those y values. And those also seem to be approaching 2. All right, let's try the next one. Now this is the same function, so you could go to Desmos and just change the values. I'm just going to go ahead and write them in to save us some time. But again, these come just straight from the graphing calculator. Sorry, I'm struggling to get on the right problem. Okay, so these values, so we're trying to find the limits as x approaches negative 3 from the left and from the right. So we want to use values close to negative 3, but not at negative 3. So the important part about limits is I don't have to know exactly what this function is at negative 3. I really want to focus on what's right around it. So you'll notice these values are around negative 3. Negative 3 would be right here in the middle. But I don't have to include that in my table. And if you were to actually look at this function, it would be undefined at negative 3. I'm going to fill in these tables, this table of values. Again, I got this just from typing in these x values into Desmos in that same function the way I just did. So for this first limit, we're looking at as x approaches negative 3 from the left. So here's negative 3 from the left. Is my x values moving? And then from the right, I would say it looks like this is approaching maybe 1.16 repeating, which is as a fraction 7/6. So we're going to say 7/6. Now it's not always easy to tell exactly what this is approaching. It's kind of like making your best guess, but you can tell that I'm not changing my x value too much. 3.1, 3.01, 3.001. Those numbers are pretty close together, and these y values seem to be slowing down as well. Same idea for -3 from the right. It seems to be approaching the same value. 1.16 repeating, or 7/6. Okay, for the last problem we're looking at as x approaches 3 from the left and the right. So again, I'm choosing numbers around 3. Notice that I am not actually evaluating at 3 itself. So again, I'm going to plug these x values in on Desmos and try to see what y values I get. Okay, so let's look at as x approaches 3 from the left. So x approaches 3 from the left is that direction. So I'm looking at these values, and maybe I just look at this last one here and say, oh, it's going to -5,000. That's actually incorrect. I can't just look at this single value here. What I want to do is take into account that I just went from 2.99 to 2.999. Not very far away from each other on the number line, but my y values increased tenfold. So that's increasing very rapidly in the y values compared to the x values. So what's actually happening here is I am going to be approaching negative infinity. I have a vertical asymptote here, so you can tell because those y values are changing very rapidly and the x values are not changing very rapidly. And then the same idea on the other side, if I go to 3 from the right, I can see that those y values are changing very rapidly, but they are going in the positive direction. And so these are actually approaching positive infinity. So you have to be careful on those. They can be a little tricky. Just pay attention to the magnitude of those y values. And so the last question is, how is this analysis related to the graph of the function pictured on the front page? And so if you look at your notes from the front page, what you can see is the answers are the same. And so for a certain function, it doesn't matter if we use a table or a graph, we should get the same answers. And next class we'll learn another way to figure out what limits are. So the last thing I want to show you is how to do these problems in Delta Math. So as you see here, we have a table of values, but it's empty. We're going to have to decide what x values to plug in. We don't actually know what the function is. It's just some arbitrary function. And it's asking us to find the limit as x approaches -4 from the left, from the right, the general limit, and the actual function value at -4. So I want to type in some values here. I can start with -4 itself. And I'm going to click try value. It's undefined. And so that means I know f of -4 is undefined. That doesn't automatically mean my limit doesn't exist, though. I might want to check a number just to the right of 4, to the left of 4. So to the left of -4, be like maybe 4.1. Let's try -4.01, 4.001. And you could keep going like this. I can try to put a bunch of zeros in and see if it works. It looks like it says it's -2.9 repeating. I'm willing to guess that's about -3. So I'm going to put -4 from the left, -3. All right, let's try -4 from the right. So that would be like -3.9. 3.99. 3.999. Then I could try a bunch of 9s just to C. And so this seems like it's also approaching -3. And then remember, if those two limits match up, then my limit is -3. If those don't match up, then the limit does not exist. So I would put DNE there. Just a reminder, limits we say don't exist, function values are undefined. I'm going to submit my answer. Fingers crossed this is right, and I'm good to go. Don't forget you can watch this help video here if you have some questions.